I was actually going to ask a question about LLMs and translation, because it seems like the way you present the tool in almost all of the blog posts is here's this natural language query. And then it's like, kind of, we hide the graph thingy off to the side and here's some results. So have you played around with that, and does it work?
Actually, yes. So TrustFall has been around for long enough that I've managed to get popular LLM tools to dump its documentation verbatim to like proving that they've been trained on it. And so they're actually quite good. They're uncannily good at writing TrustFall queries. But as is often the case, making the most of a very powerful tool like this comes down to how well is the schema design accomplished to fit the goals that you're trying to do, right? So if you have a really terrible unergonomic schema, then no amount of LLMing around it is really going to help you. Your queries are always going to be awkward. They're always going to be slow. They're always going to be unfortunate. And so that's one of the big reasons why I haven't sort of gone all in on the LLM to query language kind of thing, just because I think that there are a couple of more foundational problems to solve first. But absolutely, it's on the table. It's definitely going to happen sooner, if not later.
It's pretty mind-blowing. It's really cool. I can't help but think also about like the sort of N+1 problem that GraphQL has, where you have a query that like hits a bunch of services, and granted, I know this isn't GraphQL and it doesn't execute in the same way, but principally you have the same problem as you're querying in many data sources, and you may need to, like, if you're getting say like you're querying a bunch of users from GitHub that have contributed to some repo, and you're getting their user ID or something, and some information that's only available in their profile, you may end up having to like make a request for every user and get their profile data and like stitch that together in a larger response. And GraphQL, or the Facebook team, originally had sort of come up with the concept of a data loader, which is like some advanced caching layer, and that's hidden kind of behind the implementation. So it's like something that on the implementation side, you just like would use data loader to do smart caching and stuff. And is the same story in TrustFall? It's where it's like you just kind of have to know, it's like, okay, this could be an N+1, like a waterfall query. You need to do some performance optimization here, or is it like smarter than that? Like, what is it?
I would argue it's smarter than that. So the guarantee that TrustFall as a query engine, not talking about any specific data source, offers is this. Any kind of query optimization that you can do without TrustFall, you can do with TrustFall. So it's never going to make anything that you could have done worse just because you chose to use TrustFall, right? And it actually goes one better than what we normally do when we're optimizing stuff by hand, which is that when you implement an optimization, TrustFall will apply that optimization to every query that can benefit from it. And you don't have to go manually going in, like tweak every single query that could possibly benefit from that optimization. I can give you a specific example from Cargo-Semver-Checks. So Cargo-Semver-Checks is a tool that ensures semantic versioning compliance for Rust. And the way that it does this is it has currently about 80 queries. We keep adding more queries sort of every week. They do all sorts of things like, are there any public functions that used to exist and no longer exist? Trivially breaking change, right? Have any of their function signatures changed to take more arguments? Trivially breaking change. Have any struct fields disappeared since the last version? Trivially breaking change, and so on and so on. A common problem here for almost all of these queries is we have a language item, a function, an enum, a struct, something in one version, and we want to match it to the corresponding language item in the new version. And when I say a language item, I mean something at a specific import path, right? Because just because something is named the same thing doesn't mean it's the same thing. It has to, when I import it, that's the way that we know it's the same thing. But one language item could be available at multiple different import paths. And so this is something that's a little bit far down the language hierarchy, right? It's not like, oh, it's just the struct, right? It's like, what are all the paths? Okay, it's the same one, fine. So this is a bit of a repeating thing that almost all of our queries use. And adding one optimization that makes it possible for TrustFall to know that it has an index available, that it can in O of 1 look up, what is the item that corresponds to this path, improved all 80 of our queries. So we added a couple hundred lines of code, and we sped up Cargo-Semver-Checks by a factor of 2,300 plus. We get like 3.5 orders of magnitude of speed up with a couple hundred lines by adding this optimization that just says, we keep looking up items by their import path. Let's make that smarter, right? And importantly, what we didn't do is go through 80 individual queries and optimize each of them independently, right? So this gives us a massive amount of leverage when building this tool, because it means that when people are contributing new lints, they don't have to worry about optimizations. The optimizations are automatically applied. So we have people who are, high schoolers and people who are still in college and people who have never used TrustFall before, people who don't know anything about static analysis, who are contributing Semver lints that are running with very high performance and that are scanning, everyone's Rust packages, because we've taken the complexity of static analysis, import, resolution, performance optimization off the table. They're sort of off their plate. They're still handled. They're still happening. It's just that people that are really good at performance optimization do the performance optimizations. People that are really good at static analysis do the static analysis. And people that want to write a lint, they write a lint knowing that they get the best of the other two worlds, sort of handled for them, expressed in the TrustFall schema and made available to their queries automatically. So I think that's kind of a paradigm shift from how other tools are doing it. And I think the benefit of this is something that we've just begun exploring. I don't think we've fully realized the benefits of what this sort of mode switch of how tools are developed, what that could enable and what kinds of tooling it could lead to. Because ultimately, this is a maintainability win more than anything else, right?
Just trying to grasp the implications here. And it's pretty big. So it's read-only, query-only? Is that true?
For the time being, yes. I have some drafts for how it would be expanded to be read-write. I have drafts for how to extend the language in the system in many different directions. So, all of those will happen sooner or later as a function of funding and interest. But yes, there's no fundamental reason why it has to be read-only. It just so happens that that's how far we've built so far.
I mean, linting, for example, is a pretty broad problem. And it's interesting that we're talking about like what in some ways is a linting problem, but not exactly.
Right.
And again, I go back to the ideas, like when I think about a tool like this, generally I think about like stitching APIs together, but this is like so much more. It's really, really interesting.
My favorite example, since we're talking about stitching APIs together, at one point I got a little bit annoyed because we had a flaky job that I couldn't figure out what was going on. So I wrote a little TrustFall query over a GitHub adapter that I haven't published anywhere yet. But if someone's curious and listening to this, ping me and I'll help you get set up. I wrote a query that said the following. Look up GitHub Actions workflow runs that have run more than once on the same commit and where a job had a different outcome between, run A and run B. And that just flagged all of the different flaky workflows that we've had, right? It just flagged, here are all of the jobs that have failed, and here are the log outputs of each of the jobs that failed. And so I could tell you, like, this many of them failed because of a network glitch. This many of them failed because we failed to install some dependency because the registry wasn't available. And this is how many of them failed because of some intermittent issue that some other tool had that we were then able to, report upstream and so on. And if I hadn't had that ability to just write a query and move on with my life, let it run for 30 seconds and then get a nice tabular view that I could just, dump into a viewer and analyze easily, I probably would never have done that query, right? It's just beyond the threshold of is it even worth me understanding how to use the GitHub API and all of the intricacies and quirks, right? But given that I had this ability, I threw this query together, I got some useful data, and some benefit came out of that. And if we could scale this up, not just to the GitHub API, not just to this particular query, but to anything that anyone might be able to query, I think we've just scratched the surface of what is possible. I'm super excited for what comes next.
I was reading through your post and you said there's lots of tools that are database querying tools in disguise. What tools do you think those are outside of the ones we've talked about?
Yeah. I keep coming back to linters because I think it's an underexplored area. One big problem of adopting a linter, let's say MyPy, in a big existing Python code base, is that on day one, nothing works, right? MyPy is angry and upset about everything. But imagine that you could run a query that's hey, did this pull request make anything worse? right? Are there new errors that MyPy was not flagging previously and is now flagging? Okay, disallow those specifically, right? This is a thing that is useful for MyPy, but it's useful whenever you want to enable a new rule and a new tool and a new linter or whatever it might be, right? It'll be useful for TypeScript if you want to be more strict about using any, for example, or things like that, right? It would be useful in a variety of different places, in security, in a lot of the software development world, a lot of the tools that we use. A lot of compiler technology, next generation compilers, many of them are actually query based. The way that they do stuff is like, hey, dead code analysis. Well, is anything using this piece of code, right? For example, right? If nothing is using this piece of code, then I'm not compiling it. This is one of those things that I think, a handful of people have figured out. People have started talking about query-based compilers like 10 years ago, but I think it'll really take another 10 years before this is commonplace enough and sort of common parlance and common understanding. And so I think, we have to lead the charge and manifest the future that we want to exist in the world.